we can get started. Okay, so yeah, I'm Zabrina Ruggles, which I'm sure y'all know this by now. So my official title here is Farm Lab Manager. So I've been here for a little over 4 years now. It was 4 years in November. And so my primary duty is to manage this lab. So this lab I use for quality control for all the oils that are produced here and also for research. So I do research in here. I've written a couple papers from research that I've done right here, which is really cool. So we use all of our farm laboratories, not just for quality control, but also for research. So, and then I also work on conservation projects. So we've got a Monarch Waystation up here that I've been working on, as well as Callie's been working on one in Tabiona, and we have one in Mona. So that's been a really cool project. We also have one in St. Mary's, so I've been helping out with that one. And then, yeah, that's primarily it as far as what I do. Oh, and then random things like cooking and charcuterie boards or whatever. So it's a fun, diverse job. So I really like it. As far as quality control in the oils, so every one of our oils has what's called a raw material spec, which is a list of all the testing parameters for that individual oil, because it's going to change depending on what oil it is. So it's going to list all the chemical constituents that should be present and what ranges they should be at. It's going to also list contaminants and all kinds of stuff like that that have to be tested for. And so I use that raw material spec as a guide for when I analyze the samples in here. So I run everything on this GC-FID to look at the chemical profile of the oils. And then I also do 3 physical tests. I do refractive index, optical rotation, and specific gravity. So that's all the testing that goes on in here. I test every individual cook. So each cook will get tested, and then you've all been downstairs now and saw the barrels that we ship in. So those barrels typically take about 5 to 7-ish different batches, different cooks to fill one up. So once those are all blended together and we're ready to ship a barrel, then I test the oil a second time. And so all that data will be included on a certificate analysis that they'll receive at the distribution center when they receive that barrel of oil. So once the distribution center receives a barrel of oil, they're going to actually quarantine it, and they're going to do all the testing on that raw material spec that we talked about. I'm just going to do a little snippet of what's on there. Basically just making sure the chemical profile is good for the oil and the physical characteristics look good. But down there, they're going to do way more extensive testing. So that's where they're going to look for all the contaminants, you know, say heavy metals, pesticides, micro. They're also going to reanalyze it on a GC-FID and a GC mass spec, and so on. And so once it's released from that quarantine, then it can go to production. Hey! Oh, thanks. I need to set this one aside so I don't get confused. We can put that on in the morning. Where was I? So yeah, once that round of testing is done, they release it from quarantine, then it'll go to production, either be blended or bottled, you know, wherever it's going. And they'll do random testing throughout production. And then once you have a finished good product and it's labeled, we've got bottles ready to ship, they'll quarantine it another time and do a random sampling from that and do another round of testing, and then it'll be finally released to be sold. So it's a lot of testing.
Can you share with us why you need an extra test here every cooks?
So one benefit to that is, say we had one cook that tested out of spec, we would know that before we blended it with like 6 other cooks. So it helps in that sense. And then it also gives us a lot of data over a long period of time to look at trends. So it's, with each cook, it's very isolated as far as climate details, cook details, harvest details, as far as location or age and species of tree. We can really hone in on those details when we look at every cook. Whereas if we did a barrel could have cooks over even a different season, you know, depending on. So multiple benefits as far as that goes, of looking at trends and then just making sure you don't ruin several batches of oil. So first thing I'll do is run everything on this GC. So like I said before, this is a GC-FID, and it's going to tell me the chemical profile of the oil. So GC stands for gas chromatography, and all that chromatography is just a separation. So we're just taking our sample. You know, right now, all of our constituents are happy, hanging out together and homogeneous, and we want to break the party up because I want to see who all's here and how much is present. So that's what that does. So all we're doing is taking the sample and separating it into pieces. Are we good on time? Can we go over how it works?
Yeah.
Okay. Yeah, let's dive into how it actually does that. So first thing that happens is this syringe is going to puncture through this lid. So this is a special kind of lid that has a material that can be punctured, and then when it pulls out, the needle pulls out, it actually seals back up again. So that way we don't lose any volatiles. And then that syringe is going to inject the needle down through this hole right here. And what's down there, this is what it looks like on the inside. It's called the inlet. So this is an isolated part of the instrument that's temperature regulated to a specific temperature to change the sample from a liquid to a gas. Since it's gas chromatography, we need our sample to be in the gas state as well. And then these lines right here, these are plumbing and hydrogen gas. So with any type of chromatography, you always have what's called a mobile phase and a stationary phase. And so the mobile phase, which is what the hydrogen gas is, it's essentially like a facilitator. It's what helps carry the sample through the instrumentation. And then the stationary phase, which is what these columns are, that's what creates the separation between all of our constituents. So inside this inlet, once we reach a specific amount of sample to gas ratio, then it's going to enter into that column. So this column, it's a really fine capillary tubing. We can touch this one. This one is just for demonstration. So it's made out of fused silica. So it's glass. And it's a really fine tubing that the sample travels through. So this is hollow. And on the inside, it actually has a chemical lining. And so that chemical lining is what interacts with all the constituents in the oil and creates the separation. And how it does that is all the constituents have a different attraction to it. So it's based upon its chemical properties of each individual constituent and of the lining, the chemical lining on the inside. But the ones that are more attracted to it, they're going to be having all these quick chemical interactions with it. And what ends up happening is it'll slow the rate at which it's traveling. Whereas some of them, they're not really that attracted to it. So they just kind of fly through and travel at a faster rate. And so since they'll have a different attraction, they start to travel at a different rate. And that's what creates a separation because they'll all come to the end at a different time. And that's what's referred to as retention time. If you ever dive into chromatography for essential oils, you'll hear about retention times. The really cool thing is they never change. So alpha pinene is always going to take like 12 minutes and so many seconds to come through, and beta pinene is always going to take 13 minutes or so to come through.
Oh, is that
so? It's almost like a timestamp. No, it's like it
very
literally
exact.
Pretty exact. Like
wow.
It has it'll go out 3 decimal places, but it'll always be like within 100th of the same amount of time. Yeah, unless you were to like cut the column in half or something crazy, then yeah, it's always about the same amount of time. And so these columns are 60 meters long, so it takes a while for them to travel through the column.
What's the industry standard? Can you share with us?
There's a lot of different types of columns you can buy. Some of them are as small as 30 feet. So they don't have to be that long. The nice thing about one that's longer is it gives a lot of time for that separation to occur because of all that chemical interacting that's going on. It just gives them more time to get farther apart from each other. So, and then each sample takes about an hour. Now, most of your constituents are going to come off in about 35 minutes. They'll pretty much all be off, but then that extra amount of time just allows the column to clear. And so it'll just be hydrogen gas running through the column, just kind of cleaning out the system, making sure there's nothing else that might just pop up, So once a constituent has made it the 60 meters through the column, then it enters into the detector. And so, like I said before, this one's called an FID. We also use mass spec. So anytime like we publish a research paper, our oils will be run on both. So you use the mass spec for identifying peaks. So that's going to tell us what's present, whereas the FID is going to tell us how much is present. So when I get a graph over here on an FID GC, I've told the software that that's what it's going to see at that time. So I've run, say, just an alpha pinene standard. So I knew exactly what time it comes off in that column. And then I went in there and created a table and said, hey, at 12 minutes and this many seconds, when you see a peak, that's alpha pinene. Whereas with the mass spec, I could click on any peak and it'll pull through all these databases and it will tell me what it should be and give you a probability. Hey, it's 99% probability that that's alpha pinene. So that's how you do the two together. But this is a really good application for here because I want to know how much is present, because I want to make sure that all the ranges meet that raw materials spec before we ship the oil out. So once alpha pinene, we'll just say alpha pinene, enters the detector, the first thing that's going to happen is it's combusted. So that's the F part of the FID, which stands for flame. And since it was already in a gas state, we've just essentially super excited it, and we end up giving it a charge. So anything that has a charge is called an ion. So that I part of FID means ionization. So all that meant is we heated it up and gave it a charge. We excited it. And so now that it has a charge, there's actually electrodes inside the detector that will read how much electrical current was created at that specific moment. And that's what gives me a peak on the graph over here. So this peak I know is beta pinene, but what that peak actually is just electrical current that was captured and created at that specific time during the analysis. So the end result being this chromatogram. Get this out of the way. All a chromatogram is it's just a graph of time versus electrical current that was read. So if you ever look at a C of A and you see the graph, you're going to know now what it is. It's just time versus electrical current that was read. So the bigger the peak, the more electrical current that was read at that time, which just means more of that constituent that was present. So it's pretty cool. Yeah, we were just talking about the stability of an oil. If you really want to make sure that your constituents stay within the same range, you always want to make sure the lid is really tight and you just want to keep it in a cooler place. So if you put an oil, say, in the window where it's exposed to warmth and light, and you don't put the lid on, it's going to increase the rate at which the constituents escape from the oil, because all of those constituents are volatile, and volatile compounds escape. That's how we smell them, is because they're escaping from the liquid that they're in. So if you keep them cold, they smell totally different. So I'm going to grab a sample really quick. So this is a Grand Fir sample. So when you smell it, you can hardly smell it. So this has been in the freezer, so it's really mild. And this happens really fast. So I took that sample out, and within the amount of time we were talking in the last one, the smell changed dramatically. So this is the one that I had pulled out. So this one's been sitting out for maybe a half hour now. Just from warming. So just from it warming up, now the volatile compounds are escaping at a faster rate. Yeah. This is really interesting, huh? So if you're really worried about your oil lasting for a really long time, put it in the fridge or the freezer.
Oh.
Even the lid freezer. Really tight. Yeah, that's a freezer.
Ooh.
Yeah. Yeah, because it won't freeze because it's an oil. If it did freeze, then you would know that you had somehow water got into the oil.
Well, but oils like rose, they become jelly. What does it? Yeah, how does it work?
Why.
Oh, okay.
I don't know about the rose, but the conifers won't freeze.
Right. Yeah. Well, most of the oils, they don't get it.
That's weird. I wonder what it is with the rose.
In cold temperature, rose would become jelly.
Oh wow.
Yeah, crystal. Yeah, kind of like crystal. crystallize. And then once you put it in your warm like palms, and then it will become water again, like liquid again. Yeah. It's interesting.
That's
right?
interesting. Yeah, because I don't have rose, so I don't know.
Okay, I see. Yeah.
But that's, you know, if we do a distillation in here, like if I do a small cook, I have a small cooker, and if for some reason I accidentally got water in something, you could just put it in the freezer and then the water will freeze and you can pour your oil off and then you know for sure you don't have any water in your sample.
Interesting.
Yeah. But I didn't know that about the rose. But lavender, that one is fine. What else do I have in there? Gosh, goldenrod. Yeah, lavender, yarrow.
Melissa?
I have Melissa in the freezer. Yeah. It's fine. Yeah. Juniper. Ooh. What else is in there? The hemp samples, those don't freeze it or turn into gel.
I guess most don't freeze. Only rose is a bit different. I don't know.
I do have a standard, so I have isolated standards. That'll be like a single constituent. That's what I use to create those calibration tables I was talking about in the software, which I can show you what they look like. So like this table is one that I created. And so here's all your constituents, and I tell it what time it'll see it. Because what I've done is run just beta pinene so I can confirm that time. And camphene is solid. It's like a solid at room temp and in the freezer.
Oh.
All the other ones, they are still liquid even in the freezer and at room temp, but camphene is not. So it's interesting how different they can be. So, yeah. And here is I just got a new micro setup. I've had it now for about a year, so I've been doing that. Excuse me. I've been using that to do some Grand Fir research. So looking at the fungicidal properties of Grand Fir.
And what does it do?
On a specific fungus, Botrytis. So Botrytis is that white mold that you see on strawberries. Oh. Yeah. So we've isolated it. And I just regrow. I'm constantly growing it so I can do different stages of the study.
So this is...
yeah, so that's a microhood. So you work in there, it's got suction in it. So it's a clean space. So I'll clean my hands with alcohol and I can work in here inside the hood and make plates. So the plates, these are the plates that you grow the fungus on.
Oh.
And so you make, it's called agar, this media here. So I'll make the media, cook it in the pressure cooker. That's what that pressure cooker is for. So I'll cook it in there really hot for a certain amount of time to make sure and kill everything. And then I bring it over here into the hood and I can pour up these plates. And while they're hot, I can actually add Grand Fir essential oil. But I've also been looking at like the 3 primary constituents within Grand Fir as well to see where the majority of the antifungal properties are coming from. Grand Fir as a whole is far more fungicidal than any of the isolated compounds. With Grand Fir, I can get to a concentration where no fungus grows at all, which is really awesome. It's like total inhibition of the growth of it. I hadn't been able to do that with the isolated compounds. So it just kind of shows like the synergistic effect of all the different constituents within the oil. So that's been really interesting. So I can add the Grand Fir to the plate. Once it cools, I put it in that UV clave, which just puts UV light on it and makes sure to kill anything that may have been added, like any kind of contamination that might have been added to it while I was making it. Put it back in here, and then I can take my plates of fungus that I've been growing and add it to the plate. And then I just wait 7 days and see how much it grows.
So it's not like a vacuum place.
Yeah,
right?
It does.
It's
yeah,
just...
so when I'm using it, it does create like a vacuum almost. So I'll, use to shut the door, turn it on and make sure it runs for a while before I actually start working in it. Because I've found that if I don't let it run and kind of circulate the room within the air, that I'll get contamination. So it's been a really fun to learn. It's been a learning thing for me because I've never done micro. And it is crazy how easily you can contaminate a plate.
contaminate 到周圍嘅空間，佢係有負壓喺度，所以佢要閂門先用得呢部機。
閂門就會冇風㗎嘛？
佢啲空氣唔會喺出邊，唔會喺出邊走咗入嚟。咁佢呢度嘅空氣就淨係呢一間房咯。
Oh, I see. She's trying to explain it in Cantonese.
Oh, okay.
So,
what I can show you with the plate. I don't have because after study's finished, then I'd have to throw away the plates. Otherwise, it'll just keep growing, and I'll just have full plates.
Yeah.
But I can show you some pictures of like. Where's my computer?
佢呢度已經係殺菌，佢隻手都係無菌嘅。跟住就開咗部機之後咧，呢度係形成一個無菌空間，就唔會有啲即係理論上係唔會有菌嘅呢度係。
即係好似扮 vacuum 咁樣。
佢唔係扮，佢上面真係有嘅。
但係你通咗窿㗎嘛？
佢通咗窿，係咯。佢係應該就咁淨係擺隻手入去嘅啫，嗰個位。哦。係即係我哋做無菌嘅時候都係就係咁樣，都係有個呢個。如果你完全冇咧，佢又唔可以抽到啲空氣嘅，所以一定要有窿。
哦，我知啦，即係好似人哋嗰啲夏天咧開冷氣，跟住有風閘嗰啲咁樣嘅原理啊。一定要有個窿，如果唔係咧，嗰啲空氣咧係流唔到入去咯，流動唔到咯佢。我
just gonna try and pull up a picture of my computer. Optical, yeah. So we've got refractive index, optical rotation, and specific gravity. So those are all just going to be physical characteristics of the oil that are in. Each one is going to have its own value. Those two are basically just shining light through the oil and looking at the outcome.
This one?
Yes. And then this is a refractometer, and then that's the polarimeter, which does optical rotation. And that's the specific gravity, which is essentially just like density. It's just another way to think about density.
What do you want to know from these tests? Like, why would, I don't know.
It just ensures like the identity and quality of the oil. Yeah. It's almost kind of like, it's like an individual stamp of the oil, Yeah. It hasn't pulled up yet. So you just fill this cell up with oil. This one also has a cell. This is the cell for the polarimeter. So you just fill this up and it shines the light through this. So with this one, it's actually looking at which way the light rotates when you shine light through it, because each oil will rotate a specific direction to a specific degree. So it's just another way to identify. Yeah. And then with the refractive index, it's basically looking at how much light refracts when it's shined through the oil.
So then if it doesn't match your criteria or your standard, what does it mean? Like
that possibly maybe it wasn't the right species. Maybe it wasn't the right ratio of, say, needles to trunk material. Like there's a lot of different things like that could affect it.
I see.
Yeah. The limbs off. So you saw that the processor where they just strip the limbs off and then cut that. That's why we don't do that, because all the different chemical constituents within the plant might be they hang out in different locations, at least with trees. So some of your compounds are going to be primarily found in the trunk, and then some are going to be primarily found in the needles.
Yes.
That's why you want a good balance. So an older tree would end up being mostly trunk material. So then you might be really low or really high on certain constituents, depending on which one it was. Yeah.
So
we've done multiple
you mean depending
papers.
On the age of the tree, you get different constituents?
Well, because if it's an older tree, it's going to have a bigger trunk. So if we just chipped the whole tree, we would end up with way more trunk material than we would needle.
Oh, yes.
Yeah.
I see.
And so we actually have published multiple papers on it. I've published 2 papers, one on Grand Fir and one on blue spruce, and we've also published one on juniper, pinyon pine. Those are the ones I can think of off the top of my head. But if you go on the website, we have a whole tab now for research. And so you can actually click links to all of our papers now and read them really easy, because it's really hard to find scientific papers. But now we have them all on our website and links to them. And so all those papers touch on how, with all those trees, different constituents are primarily found in the needle, and certain ones are primarily found in trunk material. Even looking as fine a detail as like cones versus needle alone versus branch versus trunk. Some of them I think even looked at bark. It depends on which paper it is.
So do you do like a mini distillation?
Yeah, I have
like
one
that?
right here. Yeah, I've got a mini cooker. So it's like a mini version of what's downstairs. Mm-hmm. It's also got, so this is my pressure release valve, like he's got down there. And I've got a tray in here, a couple trays, so you can fill the bottom with water. And then you put this other tray in, and you put your plant material on it. So that way the plant material is elevated above the water. So
and then you
I've
just
got a condenser.
Choose the parts of the trees,
exactly.
And then you distill, and then you find the constituents, compare it.
I've got like it's basically like a wood chipper you'd use in your yard. We have one of those just for this purpose. Wow. And I've got a little electric chainsaw. So I can go I'll just go across the street and cut some stuff.
Right.
And then Michael helps me chip it. And I only need to fill this for that.
Wow.
And so this is just a mini version. Try not to break it. A mini version of what's going on down there. So this is my condenser. So I don't have a steam generator, obviously. So what I do is I use that fish pump in the sink. And so it circulates water.
This one?
Yeah. Oh, no, like this is actually it right here.
Oh.
So I'll fill the sink up with water and put the fish pump in there, and it circulates the water through the condenser for me. And then I just create steam by boiling that water on this hot plate.
Oh.
And then this is my separator. So this is where it'll collect oil on the bottom and then the hydrosol on top.
So off the head, which one produces oil from the trunk?
Oh, I have to look at my paper.
Oh, okay.
It's been a while since
Is it a little? I mean,
done blue
a few.
Too. Oh,
just a few, but most are from needles and the leaves and the branches, right?
Well, you'll find a little bit of everything in both parts. It's just that, like, primarily is it,
Primarily is from the leaves and the branches, right?
Yeah.
Okay. But might be a handful from the trunk.
That mostly come from the trunk,
I see.
Yeah.
Cool.
Yeah.
Wow.
Oh, I'm sorry. I said the oil will be on top of the hydrosol. So then what you do is you just drain the hydrosol off, and then I capture the oil at the end. I think I said that backwards.
Yeah. Oh,